Question 6. 8 marks question. Very heavy weightage again. But yet, another free gift from the marker. So, appreciate the marker's heart because later on, the second half of this paper is going to get difficult, right? So, secure marks as the easy questions, right? Do not be careless, right? Like you see here, this one says find the derivative in terms of x and y. Obviously, this is a very simple implicit differentiation, right? And they didn't even ask you to express in terms of x, right? So what you have to do, just implicitly go and differentiate this equation of the curve over here, right? Then later on, wow, find the gradients of the tangent. So simple. You see, they didn't even ask you for equation of curve. You see? Then part three maybe it is simple, but that requires a bit of some like understanding of the question. So later on I'll talk about part 3, but nevertheless, let's start with part 2 first, right? So sorry, let's start with part 1 and part 2 first, right? Okay, so question 6a is a very standard implicit differentiation question. It's the easiest you can do, so be grateful that the marker sets this question for you, right? Without further ado, you have to go and recall your content on your differentiation techniques, which I'm very sure all of you have a very solid foundation on that by now, so that is good, okay? And then the technique to go and do a standard implicit differentiation question is going to be a 4-step process, right? So firstly, I'm going to differentiate both sides implicitly with respect to x, right? Then after that, I'm going to simplify the derivatives because you know that after I differentiate, the expression is going to be like very, very complicated. So I simplify the expression, right? For goodness sake. Okay. And then once I'm done with that, I need to go and find dy dx, right? Make dy dx the subject, right? So what I'm going to do, I'm going to group the terms together, factorize out dy dx, and then after that, make dy dx the subject. And if you have done it correctly, it should be in terms of x and y. So this is the 4-step. It's a very standard procedure. You should be exercising when you are doing all such kind of questions in order to avoid unnecessarily careless mistakes, okay? And then because here you're dealing with implicit differentiation, right? Y is involved. So when you differentiate y with respect to x, it's going to be dy dx. So they thought, please remember that we are dealing with functions of y, the chain rule is going to get involved, right? The chain rule is going to get involved, right? And then you have to always ask yourself that I'm differentiating x. I need to always remind myself, right, that I'm differentiating with respect to x, right? So later on when you differentiate y, like for instance, you are asked to differentiate y squared, it is going to be 2y times dy dx, right? This is all by chain rule knowledge, okay? But instead, if you were to differentiate x squared with respect to x, it is going to be just 2x alone, right? Okay, so now let's take a look at the answer. I've drawn 4 arrows here. Each arrow represents a step. So the step 1, I differentiate both sides implicitly with respect to x. As you can see here, I have used a very simple product rule. You should know why, right? If you don't know why, please go revise your content. Then step 2, I simplify here. Then as you can see, I group step 3. I'm going to group all these terms with dy dx together such that later on I can factor out dy dx and then after that make it the subject. So nothing really special over here. Just remember to go and multiply by the dy dx after you differentiate functions with y terms with respect to x, right? All these are by chain rule. Wait, let me use a different color. Okay, so all these over here are by chain rule. Okay, so I believe that I've given you some time to get the answers already, and if not, if you need more time, you can pause the video. Otherwise, I'm going to move on to the next question. So the next question is quite simple, right? Find the gradients of the tangents, right? So all you need to do is to substitute a value for and then calculate dy dx. But since dy dx is expressed in terms of x and y, you need to go and find out what is y first, right? So because here the question says x is equal to 0. If x equals 0, calculate 2 possible values for y, and then after that you can substitute them and calculate 2 possible values for this gradient of the tangent, right? You are very lucky that here the question asks for the gradient of tangent, because sometimes the question will trick you and say gradient of the normal. If it's gradient of the normal, then we can take the reciprocal, -1 reciprocal, right? -1 over -½ for instance, right? And then, of course, ladies and gentlemen, please don't be smart, Alec. The question here asks for the gradient of the tangent and not the equation. So, Chinese phrasing, 画蛇添足, please don't fall into the trap, okay? It is not necessary. It is also a waste of time, right? So, then 6C is the part that is like a bit more challenging for this question, right? So 6C says, show that algebraically there is no part of the curve that exists for which x is less than -4, right? So when you say no part of the curve which x less than -4, which means that x can only take values which are above 4, right? Which are more than 4. X cannot take any value which is less than 4, right? So in other words, right? How do you usually read the x values of a graph? You're going to read x values by drawing what you call a horizontal, sorry, a vertical straight line, right? If you don't believe, let me give you an example. Let me go to my Desmos. All right, so I'm at Desmos already, right? Okay, so how do you usually read the x value of a graph? What do you usually do? If let's say you want to read x equals to 4, right? What I'm going to do is I'm going to draw this vertical straight line down here, right? And then you say, oh, this is the line of x is equals to -4, right? So what am I trying to imply here? I'm trying to imply if you draw any horizontal line of the equation x is equals to k, right? X equals to k, where and then you're going to have to conclude, right? What it's going to show here is that when k is less than -4, when k is less than -4, right? This vertical line does not intersect the curve at any point, which means if you go and try to solve simultaneously, right, there are no real solutions, right? So because there are no real solutions, what I'm going to do is that I'm going to have to use the discriminant and show that the discriminant is less than 0, right? So switching back to my PowerPoint slides, So what I'm going to do is that I'm going to use the discriminant method. But it's like saying, oh, okay, show that when x is less than -4, there is no part of the curve that exists, right? Or find the set of values for which x cannot take, right? Is this kind of similar question? Okay, so the same thing over here. I'm going to write a quadratic. I'm going to write in a quadratic polynomial because this, as you can see, it's a quadratic polynomial. The highest power is 2, right? So I'm going to write a quadratic polynomial in y. Right, I'm going to write a quadratic polynomial in y, and after that, what I'm going to do is I'm going to express that. They're going to express the coefficients. The coefficients are expressed in terms of x, right? Okay, so the coefficients are in terms expressed in terms of x. Later on, I'll show you what I mean. Okay, then I'm going to find the discriminant above, right? I'm going to find the discriminant above and then show that the discriminant is less than 0 and that x is less than -4, right? Okay, so some of you might be wondering what am I talking about here, right? What am I talking about in this yellow highlighted sentence over here, right? Okay, so what I'm going to do is now I'm going to jump into the answer key. Okay, so so as you can see, what I've basically done here just now, this was the equation of the curve, right? This is the equation of the curve, right? So I'm going to make it look like a quadratic polynomial in y. Why did I do so? Because the solutions for which the vertical line just now in Desmos, right? That's a Desmos. So just now in Desmos, if any vertical line is going to intersect this curve, right? These two solutions here is going to be y equals to, let's say y equals to 3/5, y equals to 1/5, right? So that is why I need to go and write we write the whole thing in terms of a quadratic polynomial in y. Okay, so Moving back to here, I'm going to write everything in the quadratic polynomial in y, right? And after that, what I'm going to do is see the coefficients are expressed in terms of x, right? That's what I meant earlier, right? So that's why I say express x squared, right? So, okay, then I'm going to use the discriminant, b squared minus 4ac. So this is a b, this is a square minus 4ac, right? And then what I do, just simplify this expression, and then I calculate and find out this is my discriminant, right? And then what I'm going to say is that because they're asking you to show there are there are no real solutions to the curve, right? That when x is less than -4, right? So I'm going to say, given that there are no solutions to the curve, right? The discriminant is ought to be less than 0. The discriminant is ought to be less than 0, right? So the discriminant is ought to be less than 0. And I'm going to get this inequality over here. So this is the cubic inequality. The moment I solve this inequality, I should be getting x less than -4. That is only where I can truly convince the marker that there is no real solution for this curve, right? When x is less than -4 and the curve does not exist. So this is a cubic inequality, right? Because they say the algebraic method, so you probably have to use the vector theorem. My apologies. Okay, so you can cheat a bit again by using your GC polynomial rule finder, because that's how you cheated back in Sec 3 also when you're solving cubic inequalities. Okay, so x plus 4 is a vector. Then you're going to find the quadratic factor either by doing a long division. So I say long division, you're going to divide the cubic expression by x plus 4. And then you can find the quadratic factor, right? Or you can alternatively do a comparison of coefficients, right? Based on your knowledge of what you have learned in polynomials, right? And once you've successfully done all this, you'll conclude that this factorized form, right, is less than 0, right? It's less than 0. But ultimately, you are going to have to show that x is less than -4, right? So in a way, you are going to have to go and convince the marker that this quadratic factor is always more than 0 for all real values of x, right? And because when later on, when it's more than 0 for all real values of x, then they are going to reject this quadratic factor. And the moment they have rejected this quadratic factor, that is when you are going to prove that x minus 4 is less than 0 and hence x is less than -4, right? So as what I said again, show that it is 1 0 for all real values of x. Can you use two ways? You can complete the square, right? And then claim that, oh, okay, x blah. Like let's say, oh, okay, I complete the square, and then let's say the perfect square is always more than equals to 0 for all real values of x. And after that, I'm going to add in the constants. All that's right. You should know all this from step 3 knowledge. Or you can also go and find the discriminant of this again. So this is like a double discriminant. This is the second time you do discriminant, right? So once you go and calculate this discriminant, b squared, so b is 1, right? Minus 4, a is 4, c is 4. So you do a simple calculation in your calculator, you're going to actually get this as less than 0. Because if I'm going to press my calculator now, right? 1 square, because 1 is the coefficient of x, so minus 4 times of coefficient of x squared is 4. So a is 4, c is the constant term, so c is also 4. Right, I'm going to get -63, right? -63. So this is definitely less than 0. And I must also show that the coefficient of x squared is positive, right? Because this is the coefficient of x squared determines the shape of the quadratic graph, right? So once I've concluded this, successfully, I can go and safely make this claim over here, right? Then once I claim this, I'm just going to solve this in linear inequality. Is so simple. Yeah, and then after that, I'm going to get this x less than -4 when its term is less than 0. And hence, I go and make this conclusion that the x cannot take the values that are less than -4. And that is the reason why when x is less than -4, the curve does not exist. So the learning point from here is like when you're asked to go and find the set of values that x can take, right? Always try to imagine like a horizontal, sorry, like a vertical line x equals to k intersecting the curve. If it does not intersect the curve, right, then it cannot take any real values of x, right? Because going back to here, the red graph, right? There is no, if you let's say I have to draw a line, they give me a wow, so let's say I have to draw a line here. You see, it intersects the curve at two distinct points. But if let's say I want to use another line, pinkish line, right? Here it does not intersect the curve at any point. So that's why there are no real solutions, right? Okay, so this is the learning point for question 6C. Because I think I've seen this in curve sketching assignments before. Because curve sketching assignments always say find the set of values for which y can take, right? Okay. So this is quite a simple question. Right? Get used to the phrasing for question 6C because similar types of questions can also appear, especially when they say using an algebraic method, right? And then of course, let's say you want to check a word, right? You can use the GC, right? So what they're going to do is you're going to use the GC, you're going to punch in the expression for the discriminant, and then if you want to show that it's really less than zero, right? The graph should lie below the x-axis, right? When x is less than -4 to show that the discriminant is really zero. So I'm going to do a quick demonstration on my GC. Please give me a moment. Okay, so ladies and gentlemen, I'm out in my GC, right? And so what I'm going to do is I'm going to key in the expression, right? I'm going to key in the expression for the discriminant, right? So it's going to be 4x cubed, right? Plus 8x squared plus 17x plus 16, sorry, 16 graph. So, wait, let me check. Did I key in? Oh, sorry. I should be, it should be 17x squared. Okay, so let me key in again. 4x cubed. Sorry for the wait, ladies and gentlemen. So 17x square plus 8x plus 16. Hope is correct now. Okay, so I'm going to get the graph out, and then after that, I'm going to go and very safely claim that here, when x is less than -4, because -4 is here, so when x is less than -4, this thing is below the x-axis. So I'm good to go, right? So after that, I'm good to go. So I've very safely proven and shown and done question 6C. Next video, we'll do question 7. Thank you for your attention. Goodbye.